Okay, in this video, we're going to explore when we're moving from moles to grams. So they're giving us the following unbalanced equations. So chromium solid plus oxygen gas will give us chromium 3 oxide. And the question stem is asking how many grams of chromium 3 oxide can be produced from 15 grams of solid chromium, which is that, and excess oxygen gas. So first we have to balance. So write out the amount of atoms for each side, the reactant side and the product side. We have 1 atom of chromium, 2 atoms of oxygen, and on the product side we have 2 atoms of chromium and 3 atoms of oxygen. So this isn't too hard to balance. Let's take care of the chromium trioxide first, since it's the most complex one. So we have, let's try 2 moles of this. So if we do that, we get 4 chromium and 6 oxygen. And so this is a lot easier to scale up from 1 and 2 to 4 and 6 rather than from 1 to 2 and 2 to 3. Yeah, this is like the lowest common multiple situation to get to this side. So we can then try to balance the oxygens and the chromiums on the reactant side. So we just add a 4 in front of the chromium and a 3 in front of the oxygen. And in doing that, we see we have 4 chromium, 6 oxygen, and 6 oxygen. Okay, our equation is balanced. So now we can find the molar ratio that we need. So they wanted to know how much chromium trioxide you get from solid chromium. And from our balanced equation, we see that it is a 2 to 4 ratio, which is what we get. So we get 2 moles of chromium trioxide product for every 4 moles of solid chromium used as a reactant. And so let's go with what they gave us in the question stem, the 15 grams of chromium. As we see here, that's our starting point to get to our desired product. And so we have our starting point and we have our molar ratio that we need. And so we need to convert this grams into moles. So look at the periodic table and look at how many moles of chromium are in, or how many grams of chromium are in 1 mole of chromium. So we need to convert. So our conversion factor is 15 grams of chromium. We'll cancel the gram unit on the denominator here with 52 grams. And this will give us our chromium in moles. So this is how much we have, 0.288 moles of chromium if we're given 15 grams of it. And so the last thing you need to do is to solve for your product of interest, which was our chromium trioxide. So we have the 0.288 moles of chromium. We're going to cancel out this chromium on the bottom from our conversion factor. Multiply that by the 2, so 0.288 times 2 divided by 4 will give us about 0.144 moles of chromium trioxide. I thought this was the end, but it wasn't. They want, so always look at what a question wants if you're ever taking an exam. They want the grams of chromium trioxide. So now we have to convert these moles back into grams. So we have 0.144 moles of chromium trioxide, and consult the periodic table again. For every mole of chromium trioxide, we have 152 grams. So that was like the 52 from the chromium. We times that by 2, it's about 100 or 104. And then oxygen, the molar mass is about 16. So 16 times 3 is about 48. So that's a total of 152 grams. And so when we multiply these numbers together, we will totally get our grams of chromium trioxide that we're going to yield, which is 21.9 grams of chromium trioxide.